In the last lesson, we learnt how to create instances for our events that we can start and stop within our game to play music and sounds. Next, we need to learn how to do the same for 3D events and learn the difference between them and 2D events. We'll then be looking at two different ways we can call 3D events in our games and how to use both of them. So unlike 2D events, 3D events have an attached spatializer effect, which can simulate distance via volume automation between the sound and the listener in-game. It can also adjust the stereo panning position of the sound to simulate the direction of its location in the space of the game. And in order for the spatializer to work within our game, however, we need to tell FMOD through our code where the source of our sound will be located in the game's space. It's worth pointing out that the fact that these events are named 2D and 3D doesn't mean they are to be used exclusively in 2D or 3D games respectively. In a 2D game such as Super Mario Bros., for example, we can use 3D events to play sounds that are far away from the player, such as an enemy jumping around. So to demonstrate how 3D events sound in a game, the first thing we need is an event we want to be heard in our game. So we're going to create an event which will play firefly buzzing sounds for the fireflies scattered around this level. So once we attach our event to this object, we'll be able to hear a change in both volume as the player approaches the object and panning as the player rotates beside it. So let's create a new folder which we're going to call sound effects, and then store another folder inside of it which we are going to call environment. Next, let's create a new 3D event inside that folder, call it Fireflies, and then assign it to the master bank. Now notice how after the master volume fader of this event, we have a spatializer effect attached. Here we can design the shape of the distance attenuation curve, the min and max distance values, which determine when the volume starts to drop off and when it ends completely, as well as other factors to adjust its size and scale in the game world. For this example, however, we're going to leave these settings as they are. So let's grab the sound we need by going to our audio bin. Let's go Environment, Fireflies, and then drag the environmental extras Fireflies loop 01 file into our events timeline. We're also going to add another loop to this track so that the region continues to play, and we're also going to go back to the music event and just turn it down slightly for now so that we'll be able to hear our new event in the game. Now if we save our project, build our banks, we'll be good to go. Now that our event is set up in FMOD, the first thing we need to do before we can play 3D events in our game is to make sure we have FMOD's Studio Listener component attached to the same game object Unity's camera component is attached to. In case you don't know, the Studio Listener is a component that comes with the FMOD and Unity integration package that, when attached to an object, provides a position for our player to listen to FMOD events from. When we play a 3D event, it will calculate the distance between the object playing our event and our Studio Listener component. It then uses this distance to adjust the volume the event should be playing at, for example to simulate the distance between the player and the source of the sound. So it makes sense then to attach it to the same object that the camera is attached to, as this will be moving through the game as our player does and will act as the source of information for the player both visually and sonically. A simple way of understanding it is by imagining that the camera acts as the player's eyes and the Studio Listener component acts as the player's ears in the game. They are the points from which the player experiences the game. Now, you may find that depending on the genre and camera position in other games, that simply attaching the Studio Listener component next to the camera like this might not be the best approach, but in our case it works fine. So if I click on the camera rig object in the hierarchy tab, click on the arrow next to it to bring down all of the children objects associated with this object, we have an object called camera brain. This object, as you can see here in the inspector tab, contains our camera component, and you can even see a preview of what the player will be able to see through this camera in the scene tab under camera preview. So because this is where our player will see from, we also want it to be where they hear from as well. So let's scroll down the inspector tab of this game object, go to add component and type Studio Listener and select the Studio Listener component. Now remember that we learnt in the last lesson that unless told otherwise, Unity will destroy all game objects in the current scene when loading into a new one. If an object like our camera rig object is needed for both, it will load a new copy of it from its assets folder into the new scene. So this means we need to attach the Studio Listener to what's called the prefab of those objects, as well as any new script we create for game objects we want to be used in multiple scenes. So in the case of the 3D game kit, I know that the prefab for the camera rig is located in the Projects tab under Assets 3D Game Kit, prefabs, utilities, and here you can see it's prefab. We know it's a prefab because if we select it, Unity will tell us what type of file it is here. So let's open it up and do exactly what we did before to add the studio listener component to it in every scene. Now this may look a little differently if you're using a Unity version older than the one I am, but for the most part it's the same process. You want to open the prefab up, you'll want to select the camera brain object, then scroll down the inspector tab, and once again add the studio listener component. Once you've done that, click the arrow in the top left of the hierarchy tab to return to the scene. Now that we've set that up, we're going to want to create a new script to play our new event. So let's go back to the project tab. Let's select Assets, 3D Game Kit, Scripts, FMOD, and just like we did last time, we'll right click, select Create, C# script, and this time we'll call our script F_fireflies, the F standing for FMOD. You can call yours whatever you like, you don't have to call it the same, but for me this is going to help me differentiate this script from any other script that comes with this game. Once the script is compiled, let's attach it to the Firefly game object that will be near where the player starts in this scene. If we go to the Scene tab and zoom out a bit with the mouse wheel, we can see our player starts here and we've got some fireflies located not too far from him. So let's click on the Effects game object under Level Assets and click the arrow next to it. Then select the 5th Fireflies game object. Then in the Inspector tab, let's scroll down to the bottom of it, drag our Fireflies script and attach it to this object. Now remember, if we want copies of this game object to load into new scenes with this script attached to them, we'd also need to attach this component to the prefab of this game object. So let's quickly go back to our assets folder and let's type in Fireflies to quickly find the prefab. This is what the prefab looks like here, so I'm going to open the prefab again, scroll down to the bottom, then I'm going to quickly find my script again, select the object, scroll down the Inspector tab and drag the script onto it, just like that. Now it's time to right click on the script and edit it. Now the first thing we need to do to our script is create a variable to store our instance inside of and tell the instance to start and stop in the same way we did in the last video. So what we can do to save a bit of time is select our old script, which was music player, highlight all of the contents within the main class, hold Ctrl+C or Command+C to copy everything, then highlight all of the stuff in this class that we don't want to keep and hit Ctrl+V or Command+V to paste it in. And now because we're interacting with a different event, I'm going to change the name of our event instance variable from music instance to FF, short for Fireflies. Let's not forget to do the same thing to every reference of that variable. Now as you can see, just like last time, we're creating an event instance variable. We're then creating an instance of that event, which we are storing inside that variable, telling it to start on the first frame, using the release command to tell it to destroy that instance once this event has been told to stop, and then on the onDestroy function, we're stopping the event once this object has been destroyed, which will happen at the end of the scene. One change to this script I am going to make is I'm going to remove the public string that was finding our event path, and instead, in the create instance command, I'm going to write the event path directly, which looked like this: event:/sound effects/environment/fireflies, and then save the script. Now if we try to play this script in game, we'd actually get a little warning message in our console tab saying that our event has not had event instance.set3D attributes called on it yet. And we won't actually hear our audio in the game, so if we quickly run over to the object, even though these are the fireflies we placed the script on, we can't hear any buzzing. So we need to fix this issue by using the FMOD command called set3dattributes. Now this is the manual approach we can take, which, if called in the update function, will place the sound to be heard in the same place that our game object is at in the game world on every frame. So let's write it out. So in the update function, let's reference our variable containing our event and write .set3dattributes, followed by 2 brackets and a semicolon. Then in our brackets, we need to write fmod unity.runtime utils.to 3D attributes and add 2 more brackets. We then need to give our command what's known as an argument. Now, don't let the term argument confuse you. An argument is a way we can pass information of a specific data type into our command. And we can do this with raw data or a variable holding data. For example, if this command expected integer data, we could either write an integer value of 5, or we could write the name of an integer variable that might contain an integer value. However, for the 3D attributes part of this command to work, it won't accept an argument of the integer data type. There are actually a few different options for us when it comes to what types of arguments we can give this command. This is because the FMOD team have pre-programmed this command to accept multiple different arguments to give you more options and ways to position your 3D events. Now, underneath this lesson, you will find a list of different argument options that this command can take, and depending on the dimensions of your game you're working on, which game object you're playing audio from, and what components are attached to that object, the option that's best suited for you may differ. In this lesson, I'm going to demonstrate just 2 of the 6 possible options you can choose from. In our case, as the game object we want to play audio from is the same one that our script is attached to, we'll be looking at giving this command transform data, and then later on, we'll look at rigid body data. But first, let's start with the transform data. Now, our command wants to know where the game object that we'll be playing this event at will be in the game world. We can give it this information by taking its positional coordinates from the object's transform component. Now, if we go back into Unity and click on our game object, we'll see it has a transform component attached to it in the inspector tab. Now, every game object in Unity has a transform component that determines the position, the rotation, and the size or scale of the game object. In our case, the script we're playing the audio with is attached to this game object that we want to play it from. So we just need to tell our script to take information from the transform component that our script shares a game object with. To do this, we're going to need to use a new data type. So far, the data types we've looked at that contain values, such as integers, floats, and booleans, are all appropriately called value data types. The other kind of data type we need for our command to work is called a reference data type, and a reference data type contains information that allows us to reference other classes in Unity. Now, every component in Unity is made up of its own code containing a main class, just like our script does. These classes are given the same name as the component itself, just like how the main class of each script we create has the same name as our script. Now, when we want to take information from these classes, we need to reference them, and to do that, we need to use a reference data type of the same name as their main class. We can then use these reference data types to create variables. Inside these variables, we can store a reference to a specific component on a specific game object in Unity. So for example, in the same way we can create a variable of the integer data type, give it a name and store a value inside of it, we can create a variable of the transform data type, give it a name, and store a reference inside of it also. Now notice how I've stored the word null inside of this variable. Null is a term used specifically for reference data types. It basically means that there is currently no reference inside of this variable. Essentially, this variable is empty and does not contain anything. So to clarify, I've created a variable called t. The data type of this variable is transform. This means that this variable can only store information that references a specific transform component in our game. If you want to learn more about value and reference data types, I'll have a link to another video on Unity's website talking more about them. So going back to our 3D attributes command, the first argument will only accept information of the transform data type. So this means we need to reference the transform component on our game object so we can tell it to play at this location here. So what we can do is store that information inside of our t variable and then use that in our command. Now to store a reference inside a reference variable, we need to initialize the field within a function. Initializing a field refers to setting a value or a reference. Therefore, a field initializer refers to the line of code where a value or reference was set to a variable. For example, line 13 in this script is a field initializer. Now the word field is a generic term when it comes to code, usually referring to any information that can be changed or edited. For example, a variable would be considered a field. So in our start function, let's write t equals, meaning we're storing a new reference inside of this variable. To actually reference our transform component, we need to use what's called getComponent. So getComponent looks like this, and it does exactly what you might expect. It gets an instance of a particular component, allowing you to adjust or measure the values and variables associated with that component inside your code. It works by taking a type inside the more than and less than signs here, And in our case, we're after the transform component, and we know that to reference our transform component, we use the transform reference data type. So we will write this inside of those two signs. It will then search through our game object for a component of the transform reference data type. It will obviously come across our transform component and store a reference of it inside our t variable. So now that we finally have a variable of the transform data type that contains a reference to the transform component, which contains a location of where our game object is in our scene, we can write the variable t in our command, feeding that variable along with the reference we've stored inside of it into our set3d attributes command. So that was just one of the 6 options you can choose from. If we were to run our game now, we'd hear our audio perfectly, but before I demonstrate how it sounds, I'm going to quickly show you a second option you could use. So the last option works well if the script playing your event is attached to the object you wish to play it from, and the object won't be moved by Unity's physics engine. If, however, the object will be, then we need to feed it both data from a transform component and a rigid body component. Now in Unity, a rigid body component is a component that gives an object physics by utilizing Unity's physics engine. Now in our case, we want to keep the game object where it is, so I'm going to quickly untick use gravity so that the Firefly's objects don't fall towards the ground. So now we need to create a new variable to store a reference to a rigid body inside of it, just like we did for the transform component. So at the top of our script, we'll use the rigid body reference data type and call it RB. And in our start function, we'll write get component rigid body. Now all we need to do is use the RB variable alongside the T variable, separating them with a comma in our set3d attributes command. So by doing this, our command will check our RB variable to see if we have an attached rigid body component on our game object. We can now save our script, jump back into Unity, and we'll play our scene once our script has finished compiling. Now to fully hear the sound in this 3D space, I'd recommend you listen to this part of the lesson with headphones on, but you should still hear the effect even if you have stereo speakers. So if I walk around these fireflies here, you should hear them pan from left to right as the studio listener component moves around the sound source. If I walk away from it, you should also hear the sound lower in volume. All of these settings, by the way, as I showed earlier, can be edited in FMOD's spatializer effect. The alternative to set3d attributes is the attach instance to game object command. Now this command can be considered a little more automatic than the last. Instead of calling this command every frame, we need to call it whenever we tell our event to begin to play. If we were to stop our event and play it again, we then need to call this command again. So in our case, it makes sense to call this command in the start function just before our event is told to play. So as soon as the game is run, the object is enabled and the event is told to start playing. We'll hear the sound and its location, so let's do that now. Let's first remove our update function as we'll no longer be needing it. Next in our start function, let's write fmod unity.runtimemanager.attach instance to game object with 2 brackets and a semicolon. Now this command takes 3 arguments or pieces of information for it to work. First, it needs to know which event instance will be attaching to our game object, and in our case, it's the one inside of our Fireflies variable, so let's add that. Second and third are exactly the same as the ones we added to our set3d attributes command, the transform and rigid body information of this game object. So just like last time, we'll separate this information with a comma, and we'll write our 2 reference variables. Now one thing to note, at the moment we're calling the attach instance to game object command before we are getting references of our components attached to this game object. Remember, code starts from the top and works its way down. So we need to store references to our components in our T and RB variables before we call the attach instance to game object command. So let's take these 2 lines, let's cut them with Control or Command X, and then at the top of our start function, let's paste them in with Control or Command V. And whilst we're editing our script, we can remove this integer at the top as it's no longer needed. Let's then save our script, jump back into our game, and we can test our scene again. And now, just like before, we can hear it perfectly. So whilst we now have our script up and running, we can shorten our script to make it a little easier for ourselves. In Unity, whenever we want to specifically reference the transform component of the game object our script is attached to, we can just write the word transform with a lowercase t, and we will no longer need our t variable to reference our transform component. If it helps, think of this as another way of writing getComponentTransform directly into our command without having to store it inside of a variable, meaning we can remove our field initializer as we've already done. Sadly, there is no equivalent for the rigid body component. However, we can directly write getComponent rigid body into our command like that. And then we can remove the field initializer and the variable itself. Great, so now we have two different lines of code we can write when we want to add 3D events to our game. We can use 3D attributes to manually tell our event to play at certain positions. We can use the attach instance to GameObject command so that our event will be placed automatically in our world when called. And with that, we've just finished module 1 of this course, so congratulations! Now that we've gone over 3D event positioning, feel free to practice using these commands, but once you have, I'd say you'd earned yourself a break. So take some time to chill out and let all of the knowledge you've learnt from this module sink in a little bit. Give yourself some time to fully understand what we've covered before moving on to module 2, as to not force too much information onto yourself. Once you feel like you've taken a significant amount of time off and are ready to jump back into things, then head over to module 2 and I will meet you there.